Hey folks, how's it going? This is Mr. Moray coming to you with a video on right triangle trigonometry, solving problems with SOHCAHTOA. Alright, so far in this unit, we've jumped in with a little investigation of special right triangles. So those are 30, 60, 90 triangles and 45, 45, 90 triangles. And then we kind of dove in to three important relationships for making sense of right triangles: sine, cosine, and tangent. Okay, so what we know is in a right triangle, given any angle, there will always be right a side that is opposite to that angle on the other side of the triangle and a side that is adjacent to the angle, right? And so, right, we know there's always going to be a 90-degree angle, right, because it's a right triangle, but we are thinking about this angle here or the angle down on the base, all right? And so what's adjacent and what's opposite is relative to that angle, right? So if I'm looking at the triangle here on the right, the opposite is the base and the adjacent is the height, because the opposite is across from the angle in question and the adjacent is next to it, right? So that's one thing that we have to consider. The only one that stays the same is the hypotenuse. That's always across by definition from the 90-degree angle. Okay, and so to remember our relationships, we have SOHCAHTOA, right? Sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Here, I've abbreviated them in the ways that you'll see on the calculator, right here on the right. And also, I just want to point out that these are sometimes called trig ratios, because it's a ratio of a side length to a side length. Briefly, we talked in class about the reciprocals of sine, cosine, and tangent. So we have sine. We also have a relationship called cosecant, which, as you can see, is just instead of opposite over hypotenuse, hypotenuse over opposite. We have secant, which is instead of adjacent over hypotenuse, hypotenuse over adjacent, right? The reciprocal of cosine. And then we have cotangent, which is the reciprocal of tangent. So adjacent over opposite instead of opposite over adjacent. Okay. And we won't talk, I don't know how much we're going to talk this year about the reciprocal ones, but it is good to know of their existence and just know that they're simply the reciprocals of sine, cosine, and tangent, respectively. Okay, so for the purpose of this video and for this part of the unit, it's really important for you to have a graphing calculator, or at the very least a calculator that can do these three features: sine, cosine, and tangent, and also these three features: sine inverse, cosine inverse, and tan inverse. And we'll talk a little bit about those in a moment as well. Okay, so in class I talked about three types of problems. Okay, so one type of problem is simply if I have a triangle and I know certain sides, can you find me the trig ratio, right? For example, here's my angle. If I want to know the sine of that, right, or the cosine or the tangent, right, to simply say, okay, the sine is 7 over 24, or rather 7 over 25, the cosine is 24 over 25, and the tangent is 7 over 24. Right here, the sine would be 5 over 13, the cosine would be 12 over 13, and the tangent would be 5 over 12, right? So to simply find a ratio if you have the sides. This I would call the easiest type of problem, and so for that reason, this problem is not going to be covered in this video, all right? Because this is just a matter of simply identifying the opposite, adjacent, hypotenuse, whatever you need to solve that problem, and simply plugging in and finding a ratio or like a decimal or a fraction. That's not as interesting or as difficult because everything is already known. On the other hand, there's two types of problems that deal with unknowns. One problem where I know an angle and I know one side and I just need to find the other side, okay? And so I need to use the given information to figure out which trig ratio do I need and then set up an equation that lets me solve. On the other hand, the other problem I could have is if I'm given two sides, to use an inverse trig ratio to go backwards and find the angle, okay? Both of these problems, again, are going to highly require the use of a calculator, because what we know is that almost never do we get an answer that's going to be a whole number? And as I said in class, I'm not going to make you, in general, remember sine, cosine, and tangent values. We did talk about the special ones, 30, 45, and 60 degrees. Those are special cases. But outside of that, I would not ask you to know by heart any sine, cosine, or tangent value. Okay, because there's no way to memorize except for the special ones. Okay. All right. So those are our two types of problems. So in this video, again, I'm going to cover the one where we have the angle and we need the sides, and the one where we have the sides and we need the angle. Okay. So at this point, if anything has kind of been confusing for you, I encourage you to go ahead and rewind and make sure you understand everything I've said so far. And then in a moment, I will start talking about some of the problems. All right, so as promised, the first type of problem is solving for a side when you have a side and an angle. Okay, so what I'm going to do is I'm going to look at my information. I'm going to try to identify an equation, a relationship, and then using that, I'm going to isolate x and solve. In this case, I would like you to please round to 3 decimal places. I'm not going to get wrapped up in sig figs. Like, I'm not about that. Just please 3 decimal places. And if there's zeros, I want to see the zeros, because to put in zeros is important. It's saying these digits are 0. Whereas to leave them out leaves me in, I don't know what they are. Okay, so putting in the zeros is actually important if there's zeros. Okay, so let's take a look here. I have an angle, right? And I have a side and a side. Now think about it. Here's my angle, otherwise known as my theta, which is just a term, like a Greek character used to talk about angle. What sides do I have when we think about theta? Well, I have the side that's opposite from theta, and I have the hypotenuse. And remember, I know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So one way you can think about these problems is, what do I have? Another way you could think about them is, what do I not have? Now think about it, right? I don't have the adjacent. We don't know what this side is on the bottom. So if you think about it, I can't do cosine because that's leaving a piece of information I don't know. I can't do tangent because that's leaving out a piece of information I don't know. Another question people have asked is, Mr. Moray, how come I can't use the Pythagorean theorem? Well, that's the whole point. If we could use the Pythagorean theorem, we would have done that. But again, for the similar reasons, we can't get x because we don't know what this is right here. So here's what I'm going to do. Notice I have an opposite side and an adjacent side. So what I'm going to do is I'm going to set up sine. Because what I don't know what the sine of 39 degrees is, but I know that it's going to be equal to the opposite, which is 7, over the hypotenuse, which is x. Okay, and so these basically boil down to 2 types of problems. Problems where x is in the numerator and problems where x is in the denominator. As you can see here, x is in the denominator, and it has to be because it happens to be that x is the hypotenuse and I want the opposite over the hypotenuse. So to isolate x, what I need to do is I need to get x up here, and then I need to get sine down there. So if I take both sides of this equation and I multiply them by x, on this side, x is going to cancel out, right? We know x can't be 0, but there's no such thing as a 0 side length, so I'm not really concerned about that happening. So what I have is I have x times the sine of 39 degrees is equal to 7. And look, sine of 39 is like any other number, right? It's not 0. It's just like anything else, right? In terms of being something we can divide both sides by, right? And look, sine 39 is likely an irrational number. It's going to go on forever. It's not going to have an exact value like that. But yet, we know that we can still divide, and if you divide it by itself, regardless of what it is, you're still going to get 1. So what we get is that x is equal to 7 over sine of 39. Now, this cannot be calculated without your calculator. So we're going to come to our calculator. The first thing we're going to do is we're going to hit mode. You only have to do this once. We're going to make sure we're in degree mode. Remember in class, we talked about two things. We talked about degrees and another system of measurement called radians. We're not going to talk about radians right now. We may talk about them later. So for now, we're going to stay in degrees, but you need to make sure that if you're working with degrees, the calculator knows you're working with degrees, because if we learn about radians, you're going to see that 39 radians is much different than 39 degrees. So we're not looking for that right now. So I'm going to go ahead and I'm going to exit out, knowing that second quit, knowing that I'm in degrees, and I'm going to do 7 divided by sine of 39 degrees, close out my parenthesis, and my calculator says 11.123. Okay, so therefore the hypotenuse is approximately 11.123 units long. Someone did ask me in class, Mr. Murray, do I need to use units? Here's what I'll tell you, at least for me. If you don't want to use units, that's fine. The only time I'm going to make you use units is when there's a specific context. So if I told you that, hey, this ramp is going up by 7 feet and it's on an incline of 39 degrees, how long is the ramp? Then I'd expect you to say 11.123 feet, because I had specifically designated a unit for length. In this case, I haven't, so I'm fine for now if you leave it 11.123. Okay, now I have a different type of problem down here. So here, let's take a look at what I've got. I've got a measurement. I know I have an opposite side of x. I have an adjacent side of 7, and I have an hypotenuse of unknown, right? If you don't see a number, what you should think is this is unknown. Okay? I'm just going to draw a barrier around this. This is unknown. So you can assume that any ratio that includes the hypotenuse is not one that you can use to solve this problem. So if we take a look, sine, I need the hypotenuse. Cosine, I need the hypotenuse. But notice tangent, all I need is the opposite and the adjacent. So in other words, I know that tangent of 47 degrees is equal to the opposite side from it over the adjacent side from it. Okay, this is problem type 2, because this is a problem where, notice, x is on the top rather than on the bottom. Right here the number was on the top, so this is a little bit different and even a little bit easier, because now all I have to do is multiply 7, which cancels out there. So what I know is that x is equal to 7 times the tangent of 47 degrees. Now look, again, I don't know the tan of 47 degrees. So what am I going to do? I'm going to come to my calculator. I'm going to do 7 times tan of 47 degrees. My calculator tells me it's approximately 7.507. Okay? So that means this is approximately 7.507. And think about it, that kind of makes sense, right? Because look, this is almost a 45 degree angle, and we know that if it was 45, that the base and the height would be the same. And that's basically what we're seeing, right? We're seeing that they're only 0.5 of a unit off. They're practically the exact same, okay? And so that's a good sign, right? That checks is what we know, or we should expect when it comes to a 45, 45, 90 triangle, okay? Okay, so this is what we have so far. We have a situation where one of them, we have the variable on the bottom, and I think actually what I want to do is I don't want tan, I just want to clarify, this is, make sure we know this is 47 degrees. Okay, I changed that, I just want to make sure I update that there, that's 47. Otherwise this math wouldn't make sense. Because notice how I originally had 42, yet this came out to be longer. It is true in triangles, so like this is a 90 degree angle, this is a 47 degree angle, so that puts me at 137, and so this would have to be a 33 degree angle, actually a 43 degree angle. It's 43 plus 47 is 90, plus 90 is 180. So what we'd expect is that if this was 47 and this was 43, you can see that they're almost 45, so they're almost the same, but this is 47, so this one's going to be a little bit longer, because the longest side of a triangle is always opposite the longest angle. The medium side of a triangle is always across the next largest angle, and the shortest side of a triangle is always across from the shortest angle. That's true, right? Because the angle indicates a sense of openness between two lines, and essentially the longer these lines are open, the wider they're open, the larger the angle, the longer the side you're going to need to connect the ends, right? If you think about it like that. So in any case, two types of problems. One in which we do the simplification and we get an equation where x is on the bottom, and one where we get the x's on the top. So you have to be ready to look for those, and one of them is harder than the other, but you just have to be aware that either scenario could play out. Okay, so please make sure you understand what I did there, rewind if needed, and then in a moment I will move on to the next set of problems. All right, so now for the we try problems here. So here, let's try them together. So first, let's take a look at this triangle right here. Okay, and if you need to go back and rewind to see the trig ratios, I would suggest you do that. So I have a 63-degree angle, I have an x, and I have a 10. Based on what I have here, what sides do I have? I have the adjacent side and I have the hypotenuse. So what are my options? Essentially, I have to use which of the three ratios? I have to use cosine, because cosine is adjacent over hypotenuse, right? So cosine of 63 degrees is equal to x over 10, okay? Because it's adjacent over the hypotenuse. So what this means, if I multiply both sides by 10, 10 times the cosine of 63 equals x. So how do I get that? 10 times the cosine of 63. By the way, you don't have to put the multiplication sign between. If you don't, it will know how to multiply on this like a TI graphing calculator. So what I get here is I get 4.540, because I've got to round this to up to a 0, and that will spill over. Okay? So that's what I get there. All right. So let's just check to make sure that makes sense, right? So if this is a 63-degree angle, well, then what this is this is a 27-degree angle, because 63 plus 27 is 90, plus 90 is 180. So as we'd expect, this is going to be a relatively shorter side, and this will be our medium side. We actually now can find the last one simply by using the Pythagorean theorem, because we have a squared and c squared. We would just have to get b squared. All right, now for the next we try. So I have my angle of 51 degrees. Which sides do I have? I have the adjacent. I have the hypotenuse, not the hypotenuse, the opposite. So based on that, I'm going to use which of the trig ratios? I'm going to use tangent. So I'm going to set up tangent of 51 degrees is equal to 12 over x. Make sure you got 12 over x and not x over 12, because tangent is equal to opposite over adjacent. Remember, right? Opposite over adjacent. So opposite in this case is 12, because this is the angle. So that's where it's relative, right? Because if this 51 was over here on the other side, then it would have been a completely different setup, all right? And that matters. It's important, because the sides matter. You get a completely different relationship if you don't do this in this specific way. So now I'm going to solve. My first step will be to multiply both sides by what? By x. So that's cancel. The x comes over here. Then my next step, so I've got x times tan 51 is 12. What's my next step? Divide by the tangent of 51. Okay, so this cancels. So now what I need is 12 divided by the tangent of 51. And that gives me approximately 9.717. Great. So 9.717 is the answer there. Again, just a different technique. Instead of just multiplying, I just need to rearrange. I need to get the x up here and the tan down there. And once I've got that, I now know my x. Okay, so again, please make sure you understand these ones thoroughly, as in a moment I am going to move on to the ones for you to try. All right, so these are going to be the you tries. I really recommend you have access to a calculator at home. You know, if it's not a graphing calculator like the one you see here, it needs to be able to do at the bare minimum sine, cosine, and tangent. Okay, any scientific calculator will be able to do that. All right, so please make sure you take a moment, pause the video, try to do these problems. So we're finding x, and then in a moment, when you think you got the answer, unpause and I'll show you how to solve. All right, here we go. So we're solving these for x. So what I'm going to do here is I've got my 29 degrees. I see I have my adjacent. I see I have my hypotenuse. So I'm going to set up cosine of 29 degrees is equal to x over 19, adjacent over hypotenuse. So x is going to be equal to 19 times cos 29. 19 cos 29, boom. So that's approximately 16.618. And if you want to add units, you can. Okay? So see, once you get in the swing of it, the problems actually do go pretty quickly. Okay, how about this one? So here I have a measurement, I have the opposite and the hypotenuse. So I've got sine of 36 degrees equals 29, the opposite, over the hypotenuse. Okay, I manipulate stuff. I have x sine of 36 equals 29. So x equals 29 over sine of 36. Okay, some people don't do this intermediate step. Some people just flip them. And that's okay, right? They just flip the x up and the sine 36 down. And you can do that, right? Because that's essentially just multiplying and then dividing. So you do it however you want, as long as you do it in a mathematically sensible way. If you throw out that step, if you don't do the intermediate step, I'm fine with that, because to me it's clear what you're doing there. You're just getting it alone, so that's fine. So I do 29 over sine 36, and I get 49.338. And if you think about it, it makes sense, because we would expect the hypotenuse to be much longer than any side, including the height. Okay, so that's a little walkthrough of how we do the first of the two major types of problems we're going to cover in this video. That is, when I know an angle and I know two sides, can I, one, identify sine, cosine, tangent, and then two, can I use that and manipulate an equation, and using my calculator, can I find an unknown variable? So please make sure you understood what I did here in these problems. Rewind if needed, and then in a moment I will move on. All right, so I'm going to go ahead and move on to solving for an angle when you know the sides. So I'm going to go now the other way. First I solve for sides when I do an angle. Now I'm going to solve for an angle when I know the sides. So to do this, what I'm going to bring in, and I talked about this in class, is I'm going to bring in what I call the inverse trig ratios. So just like we talked about inverse functions a few units ago for different kinds of functions, we also have inverse functions for sine, cosine, and tangent. And they're called: sine goes with sine inverse, which is right above the sine button on your calc. Cosine goes with cosine inverse, above the cosine button. Tan goes with tan inverse, above the tan button. So when I'm using sine, cosine, and tangent, I have an angle, and I know I'm going to get, what it's going to give me is the ratio of the sides. So for example, if I do sine of 36 degrees, what I get is, so sine of 36 degrees, you give me an angle, and I give you the ratio 0.588, let's say. So if I have an angle of 36 degrees, the ratio of the side that's opposite to it, to the hypotenuse, will be 0.588. Sine inverse, cosine inverse, and tan inverse work the other way. They work by saying, if I know the ratio of the sides, can you tell me the angle that had that ratio? So in other words, if I know that, let's say I know that the ratio of the opposite to the hypotenuse is 0.588. What the sine inverse function tells me is, hey, the angle that's opposite that side is about 36 degrees. So see what we get here? We plug in an angle, we get the ratio. We plug in a ratio, we're back at the angle. So there's that idea of them undoing each other. So what we're going to do in these problems is we're going to first identify the information that we're given. We're going to then identify which relationship makes sense to use, the sine, cosine, or tangent. And then we're going to use the inverse of that to go from a ratio back to an angle. All right, so I'm going to start with the I try problems here. And so in the I try problems, I'll show you what we're going to do. So here I have an angle, and what I have is I have an opposite side and I have the hypotenuse. So I'll do this in blue. So what I know is I know the sine of the angle theta is equal to the opposite over the hypotenuse. So what that means is that the angle is equal to the inverse sine of 7 over 25. Because if I take the sine inverse on the left, the sine and the sine inverse cancel out, leaving me the angle. So here's what I'm going to do. I'm going to do sine inverse of 7 out of 25. And my calculator will give me approximately 16.260. Here we put the degrees because in this case it matters that they're degrees, and I want to see that unit coming out because that unit is clearer than the unit for length. In length it could be units, it could be feet, inches, centimeters. That's ambiguous. But angles we know are degrees, so I should see degrees there. Okay? Down here what I have is and which sides do I have? I have an opposite and an adjacent. So here I know that the tangent of the angle I'm given is equal to the opposite over the adjacent. Okay, so in other words, the angle is equal to the inverse tangent of 12/5. In other words, if I know that the ratio of the opposite to the adjacent is 12 over 5, then the angle that corresponds to that ratio is about 67.380 degrees. Okay? So please make sure you understood how I did that, because in a moment I am going to go ahead and speed up and do this a little bit faster. All right, so now the we try problems. So here we go. This one I'm going to kind of give you a little bit of opportunity to chime in before we move down to the you try problems in just a minute. So here I have my angle. And relative to these angles, what two sides do I know? I have the adjacent and I have the hypotenuse. So based on this, what relationship should I be targeting? I'm going to target the cosine relationship because I know that cosine of theta is equal to 10 over 19. Remember, theta is our angle, which means that theta itself is equal to the inverse cosine of 10 over 19. Which is approximately equal to, let's see, cosine inverse, so second cosine, 10 out of 19. And that is about 58.243 degrees. Okay, how about this one? So here I have an angle. Which two sides do I have access to? I know the opposite and the hypotenuse, so I'm going to target which relationship? I'm going to do sine, so I know that sine of theta is equal to 50 out of 82, so therefore the inverse sine, so therefore theta, I guess we could say, is equal to the inverse sine of 50 over 82. So in other words, say I know that the ratio of the opposite to the hypotenuse is 50 out of 82, what angle would have to be the angle with that ratio? And that's what the inverse sine tells us. So this is going to tell me if I know the ratio of the opposite to the hypotenuse is 50 over 82, then the corresponding angle measurement is 37.572 degrees. Okay, so in a moment we will move on to the U-try problems. Please make sure you do understand what I did in these two, including how I figured out the relationships, how I plugged in the sides, and how I set everything up. And then in a moment again, we will move on to the U-try problem. All right, so again, for the U-try problems, it's going to be the same deal. Please make sure you take a moment to make sure you have access to some form of calculator, whether it be a graphing calculator, whether it be a scientific with sine, cosine, and tan, an inverse sine, inverse cosine, and inverse tan, or Wolfram Alpha, where you can type in what is the inverse tan of blank, okay? Or inverse sine or inverse cosine, okay? So again, please pause the video, try to solve on your own, and then in a moment, I'll show you how to solve these ones. All right, wow, so here we go. So here, what I know, I have my angle, I have the adjacent, I have the hypotenuse. So I'm looking at the cosine of the angle being equal to 21 out of 125. So therefore the angle is equal to the inverse cosine of 21 out of 125. So let's do that. Inverse cosine, 21 out of 125 is equal to 80 degrees. So theta is approximately equal to 80.328 degrees. So you know me, I like my figures not drawn to scale. So just keep in mind, no figures are going to be drawn to scale with me. Sorry about that, but kind of not sorry. Okay. Next one, what I've got is, I know I've got my angle, I've got my opposite, I've got my adjacent. So I'm looking at the tan of theta being equal to 38 out of 17. So theta is going to be equal to the inverse tangent of 38 out of 17. And so I'm going to do second tan inverse. I'm going to do 38. I'm going to do out of 17. And what I get back, I like to close the parentheses. I recommend you do too. Theta is approximately 65.898 degrees. Please make sure you put degrees on there, okay? So again, I encourage you to really make sure you're understanding where these problems are coming from, but more or less that's going to close things out, okay? So in this video, I talked about recalling what are the three relationships, the three ratios, right? We have sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, tangent, which is opposite over adjacent. We briefly touched on, right, the reciprocals. We talked about the three types of problems overall that we see generally when we talk about sine, cosine, and tangent. All right, and then we walked through two of them in specific. What happens when we have a side and we need another side, or what happens when we have a side and angle and we need to find a side, and what happens when we have a couple sides and we need to use the inverse sine, cosine, or tangent to find the angle. Okay, so I hope you found this video to be educational. I hope you got something good out of it. Please stick with it. Remember to stay positive, keep the questions coming, and remember, no matter what, you can do it. All right, thanks for watching. Keep the questions coming. Don't forget to like or subscribe so you can get all my new videos and be aware when they come out. And don't forget to love math.